Okay, so guys, we're starting. Whoever comes late, because there's a stream, it's going to be a video, we're going to have to just have a look at that. Yeah. Right? So, who has an idea of what OOP is? Or who has ever heard of OOP, or object-oriented programming?
Isn't this the fundamentals of software engineering?
It depends on who you ask, but yeah, we could put it like that. So what basically OOP is, it's a style of programming. Like for instance, the one example I like to use is like cooking. If you want to cook like chicken, you can boil it, you can roast it, you can fry it, you can, what else is there? It's all cooking. Yeah. So same thing with the programming. It also has styles. The normal style that we use, that we have been using since is procedural, where everything is just line after line after line after line, up until you get to the end where you hopefully export your CSV. Yeah. So that was procedural. So OOP is another different style. We also have functional programming. We also have, okay, I forgot what it's called, but another huge style is functional programming, like the one being used by DEX and all those things. Now, fortunately, Python uses all of those styles of programming, right? So what it is how it came about was programmers, I don't know if it was the late 70s or 60s or anything like that, they decided, someone thought, okay, wouldn't it be cool if we were to design programs using a similar style of how we design physical objects? Is it like how we design cars or how we design shoes or anything like that? Instead of heavily focusing on doing everything like in a maths-based way, wouldn't it be nice if we had like blueprints for software, if I can put it like that? So that's how it came about. And one of its main benefits is it's really good for code reusability. Meaning if I design something and it works, if I've designed it in OOP, I can actually give it to you and say, with very few instructions on how to use it. And you could actually create your own things like 1,000 or 1,000,000 times. Like for instance, when you're creating a pandas DataFrame, you just go pd.dataframe. We've done it 100 times without ever thinking of how it's actually working in the background. That's all OOP. So yeah, that's that. And with object-oriented programming, okay, the most important thing is the object itself. Okay, so what is an object, or how do you identify an object? Basically, all objects have three things. It has an identity, it has attributes or features, and then it has specific behavior or methods. All objects have those things, right? And the nice thing is, if you're a Python programmer, you don't need to worry about memorizing anything because everything is an object. In Python, a string is an object, integer is an object, function object, even an object itself is an object. Everything is an object. So yeah, okay, let's start off with something here. So here I'm just going, I take the variable x and I assign it to 3. So when I return it x, it returns 3. So what it's doing here is just saying the variable x is pointing to an object, and that object, the value of it is 3, right? And when you type something, when you want to check the type of anything, you are actually checking the type of object there is. In this case, it's just an integer. And with all objects, because they have specific behaviors and they have specific attributes associated with them, when you go print directly, it will tell you, it will return everything about that object, what inherent methods and attributes that come with it. And because this is an integer, you can get your absolute value, you can add, you can use bool. Okay, I don't know where you use bool, but an integer, but okay. You can check, you can return the ceiling of it, all those things. But I think this is reserved for floats. Or maybe it's that whole custom thing. Okay, but these are all the things that you can do with an integer. Right, and the one thing that you're going to hear a lot of with regards to objects or object-oriented programming are the 4 pillars of object-oriented programming, which is something we should expect in an interview, even if you're data science. This question comes up a lot, as in, what are the pillars of object-oriented programming? Summed up, you just have to remember a pi, right? So what the pi stands for is the first pillar of object-oriented programming is abstraction. So abstraction is basically that each object is its own idea. As in, a vehicle is an idea, a house is an idea by itself. So then that's abstraction. And then you also have polymorphism. Now, polymorphism is the idea that each object can have different shapes or can attain different shapes. Like for instance, when you're using add, if you go integer 1 plus 1, it returns 2. But if you go string 1 plus string 1, the answer is string 1, 1. So the add function inherently knows that if things come as integers, it deals with them in a certain way. If they come in as strings, it deals with them in a certain way. So that's polymorphism. So it changes shapes depending on how you're using it. Another important pillar of OOP is inheritance. Inheritance basically is what you think it is. The ability of an object to get certain features or attributes from a different object. Like for instance, we inherited the genes of our parents. That's why we look like how we look. So objects also have the same characteristics. Last one is encapsulation. And encapsulation is basically that each object has the ability to lock in certain information or methods or attributes within itself. As in, maybe let's say for like an example, a model inside knows which tuning parameters it's using, all those things, but it can't decide to not show it to you, even though the information is there. So there will be like encapsulation, so everything can be locked up inside an object. But there's ways of getting those things, especially if you're using Python. So yeah, those are the 4 pillars of object-oriented programming. And the main workhorse of OOP is the word class, or the keyword class. If you're reading source code and you see something or you hear someone mentioning something about a class, that person is talking OOP, right? So what a class is, it is both the template and the factory that creates an object. So for instance, like you say, if you're building a house, it is the actual blueprint of how a house should be built. But then if you want to build a house, the same template is going to be the one that actually constructs the entire house for you. So that's what a class is. That's what a class does. It's a template and a factory. So now to create an object, your own object, if I can put it that way, is you basically call the keyword class and you give it a name. And the naming convention for a class is just normal camel case singular, as in class, shoe, house, data frame, not data frames or anything like that, or my data frame, no, just singular. So we just go class and I just put the keyword passage so that Python doesn't crash. And yeah, and whenever you check the type of anything, you're basically asking what class was used to create that object. So in this case, or at the top here, we created the variable x, which was an integer. So there's an actual class inside Python called integer or int. Now we get to an example, right? We create, let's say we wanted to create a society. To create a society is made up of people. So because when naming your object or naming a class has to be singular, we just gonna say class person. So to create this society, it's gonna be made of individuals. So the first, let's say we create the first individual. This first individual, give it the variable name Muzi, and then we create an instance. Now here's what's important. When you're looking at this part, where this is the class name, and then you have these 2 brackets. The 2 brackets tell Python, hey, from the class, I want to create an instance of an object. So we could create 100 million of people, or of persons from this. This is a similar thing to when we're creating a model, where we say logistic regression, LM is equals to, no, LR is equals to logistic regression, open close bracket. You are saying create a new instance of a model. So we run this, and when you ask Python what type of object is this, it tells you. This thing was created from the class person, so it's a type person. And then as with objects, all objects have an identity. Okay, this one already, we've already given an identity, okay, with the variable name Muzi. Also has to have attributes and associated behaviors. So with attributes, because it's just a blank class for now, you can actually go in and say, instance name dot whatever is equals to something. We are basically assigning a new attribute to the instance of the class. So now when we go to the instance name and we go here, we're just assigning the gender, just saying Muzi.gender is equals to male. So when you ask this instance, what is the gender, it returns the string male. But if we were to create everything like this, it would be tedious, right? So one of the things that helps with classes is you can actually create your instances with certain attributes right at the beginning, at the gate. As in, if you're creating a data frame at the gate, it's going to have rows, it's going to have columns, it's going to have an index, all those things. And to do that, Python uses what's called, okay, all programming languages use what is called a constructor. In Python, that constructor is a function, like a normal function inside the class. So inside the class, 4 spaces, you create a function with this keyword, with this word here, the init here, with the double underscores in front, double underscores at the back. It's called a data init. So whenever you see something with two underscores on both sides, those are internal functions. You can override them, but Python uses those functions or those keywords for itself. So what happens here, let's say we're creating a person, and this person is going to have a name and a gender right at the gate whenever we're creating a person. So with this function, here's the interesting thing that happens. We're only going to create a person with a name and a gender, but there's 3 attributes that I'm passing here. Now, the first attribute, this self thing here, this is basically a pointer that points to an individual instance, like each instance that gets created. Right? Self you're not forced to put in self, but then it's industry standard in Python is to use self. With other languages, they might use this, I know, but most languages use this. So what happens is, let's say we're creating a person. We will say, let's say the person we're going to be creating, that person's name is Muzi. So the self will stand for the instant Muzi. So it'll be Muzi.name is equals to name, or Muzi.gender is equals to gender. So let's join this, and then we try and create an instance of person, and Python complains. Now the reason it's complaining is, unlike the first time, now we told Python, whenever a person is created, they have to have a name, they have to have a gender. So we come to this part. So now we say, okay, Muzi, person, inside the brackets, we pass in the name, we pass in the gender, and we run this. Python doesn't complain. When we check the name, it's Muzi. Check the gender, it's there. Right? And if you want to know what attributes any object has, you just go use the dunder date. So this will tell you the attributes of the particular object, or the particular instance of the object. Okay, now here's the problem. Here's another thing to keep in mind. Whenever you're dealing with objects, you are always either dealing with the instance of the object itself or the class that created the object. So in this case, this is the same code as above, where we're creating a person Muzi, right? So anything that has any function that comes with the keyword self, that function has to deal with the instance of the class, right? But then we can also pass in attributes that are class attributes, meaning everything that's going to get created automatically is going to have these particular attributes. So in this case, we're just saying that the class attribute is nationality. We say we're giving it South African. We create a new person, okay, let's call this person Noko, and she's female, yeah? We run this, when we run this, we didn't have to specify the nationality, but because the class that was used to create Noko has the attributes nationality, Noko by default is South African, because that's what the class says. Do you have a question?
Yeah.
is the nationality only to Unoko, or can you say, like, when you access static variables, can you say person but nationality? Would you get South African? Or
Yeah,
do you
okay.
have to?
Yeah, you can. If you want to check what the attributes of, okay, if you say class name dot attributes, yeah, you can get it like that.
Is this an example of inheritance?
Not yet, no. This is, okay, wait. Is this an example of inheritance? No, it's not. No, it's.
Because like, what I'm thinking is that like, you say person, but then you're saying whatever you put within person.
Yeah, an example of inheritance would be a class getting certain information from a different class.
Okay.
Yeah, so for now, this information is all contained in one place. But we are gonna get into inheritance. Okay, now what this creates is it creates a situation where there's actually both instance variables or attributes, and there's also class instance variables or attributes. Like for instance, we go local gender is an instance attribute. Let me just call them all attributes, right? We could also, just because local was created female, we can go in and change that and say local.gender. So we're saying this attribute, change it. We're making it male now. So when you check, local is now male. When you check all the attributes, okay, it tells you this is what local is. But then the thing is, it doesn't show you the nationality, because the nationality is a class attribute. To get that, you have to put in the class name and ask for the standard date of the entire class. And then it tells you, no, one of the things that it has is this, the attribute of nationality. Okay. Or yeah, we can also do the same thing with the class attributes. You can go class name dot their attributes and then just change it. So now, there are specified population. Okay, I must have been fiddling around with the notebook and I changed something. Okay, this shouldn't be clear. Okay, now let's talk about accessing class variables or attributes. Same thing as above, but then what we've added now is population, meaning whenever an instance of a person is created, we're gonna now add a count for the population. What we do is the constructors, same as above, but then underneath everything, we just say class name dot population plus equals 1. So then with each instance of a person underneath the class, it's going to keep count of how many instances have been created. So if we run this and then we create 3 people, when we go person dot population, it tells you, okay, there's 3 instances that have been created. This helps out a lot if you need to keep track of how many things are getting built. Yeah, and then everything we've talked about is all attributes of an object. We're now going to go into the behaviors of an object, right? And with the behaviors, it's just methods. Same thing as above with the initializing of a person and the class attributes, but now the one thing we're adding is the function greet. What this is going to do is each instance is going to have a method of greeting, as in each person is going to have a way of greeting, right? So we're saying, we define the function, we put in self. The self is very important. It's the thing that tells Python that this function is going to be associated with each instance with each instance. So we say if a nice way to help read object-oriented programming is to try and create an instance in your mind and not use self. So we're creating people. Let's say for instance, for this, the first person who's going to create is Muzi, and just change the name self to Muzi. So we say if Muzi.gender is female, then return good morning. Else return how's it chief, which when we create Muzi is going to be male. So Muzi is not going to say good morning. So that's how I read source code that's been designed using OOP. So let's run this, and now it creates 1, 2, 4 instances of people, and it's a mix. Some are female, some are male. So the first one here, Shanae, is female. So when we ask Shanae to greet, because of being female, she says good morning. When we ask Dustin to greet, it's how's it, chief? So yeah, those are behaviors inherent within each object. So they call them, methods. It's a function within an object. And if you forget to put the self, you're just going to have a generic function. Python will not know how to link the actual function to every instance that gets created. Yeah, so there was what? There was the instance methods. Now we look at class methods, as in the template itself. It can also have its own behaviors, because it can also have its own attributes, but also its own behaviors. Same code is above everything in the grids. But then now, when you're creating a class method, things change a bit. And what happens is, we have this, you still put in a normal function. With this, because we're creating a society, there's going to be a method of checking how many people have been created in this society. So it's a function, get population, but instead of passing self, which is reserved for the instances, we use CLS. CLS basically says, this function I'm creating now, associated with the actual class, and not the instances created from the class. So you put in this, so what it's going to return is, it's going to be the class name dot population. So it's going to be person dot population. And what's important is you're going to see a lot of this in source code inside the Python source code, which is called class method. It's a decorator. A decorator basically ensures that this function is only going to be used as a class method. So you can get a population side, population amount, but we can also change something with regards to the class itself. For instance, with this class, we have this attribute called nationality, which is at the moment is South African. If you wanted to change everyone and say, okay, everyone, you're no longer South African, you are, I don't know, Mexican now. We would use this class method, which takes in CLS and whatever attributes you want to change. So this is known as a getter method. So it goes in and gets certain information. The one beneath is called a setter method, as in it goes in and sets something. So we run this, we create a whole lot of people, and now we go Python, we go class name dot get population. And when we run this, Python returns 6 instances have been created. And this is important, the 2 brackets, because whenever you do something and when you put in 2 brackets, you're basically saying the thing that you're running now is a method of some sort, or is creating a certain instance of some sort. And then we go, and now we say person, we change the nationality from South African. Everyone now is going to be created from this point onwards. If you want them to be Chinese. So we say class name dot set nationality, which is a class method that is inside here. And we set it to Chinese. So now the next person we create, in this instance is Andy. We create Andy. When we check his nationality, Andy is not South African, like everyone that we created before we changed the attribute. Everyone now that we create is going to be Chinese.
So it doesn't backdate.
No, it
so the instances you created previously, it doesn't update them.
No, it doesn't, but you can create code to go back and change
and do that.
Yeah.
So if you type in Muzi.nationality, it's still going to say South African?
Yeah, it has to.
You also Chinese.
So change
Okay, change it. Hey, learn something new every day. Okay, thanks for asking. I always assume it just moves forward. Okay, so change the whole class.
I have another question.
Yeah.
The instances, can you get it directly from the object? So like music.get nationality, does that work, or does it have to be the class person.
Get nationality.
Like,
I think because of how we created it, it will have to not work because we specifically said this is a class method. But let's check, because I also need to know if we can actually do that. What was it again? Get.
nationality. Okay.
Or we only have set nationality.
Get population.
Or get population, yeah. This should be interesting. Population.
Okay.
Oh yeah, the child has access to the class methods. Wow. Okay. I don't know how I missed that one. But yeah, it works. What else? Okay, this is, oh yeah. Because, yeah, it does have access. I actually go to check. Like, Andy's nationality was Chinese. So we can actually change just him to make him Mexican. But let's check if Muzi is still Chinese. Yeah, Muzi is still Chinese because we only changed Andy. Hey, you learn something every day. Oh yeah, another important thing. For attributes, attributes are not only just straight up integers, strings, or anything like that. You can actually assign an entire function to create an attribute for a class or a method. With that, you have to put in a function, just a normal function, but then you have to put in this thing. This is called the property decorator. Whenever you see anything about a function with the add symbol, that's a decorator. So what's happening here is we're telling Python, that listen, inside this class, we are turning this function into, read this function not as a method, but as an attribute. So whatever this function returns. So what's happening here is we're creating a class student. It takes in the name and the surname. But what's going to happen is we also want a new attribute, which is the email address. So the email address will get created from both of those things. So it's the instance's name and the instance's surname at school.com. So now we run this, we create an instance. When we check that instance's email, it comes up as muzi.java@school.com. So we didn't have to do that whole open close bracket thing because it's not a method. It's not, Python is no longer looking at it as a method. It's just looking at it as one value of some that comes from this. It's an attribute. Yeah. And this, what do I want to say here? I actually want to come to this part because this is very important. I just am importing pandas. I create a new data frame. What I want to show is, yeah.
The attributes aren't included in the dictionary labels.
These are the basic.
The properties.
Yeah, these are like the basic attributes they get created. If you want to see everything, it's directory. And then it's somewhere here. Where is it? There it is.
There it is.
Yeah. So we created a new data frame. Oh yeah. Whenever we create a data frame, we go pe.dataframe. But initially it's like this. You just say from pandas, there's a module called DataFrame. Create an instance of a data frame. But normally we don't do this because they'll return just an empty data frame. We pass in certain information. And from the constructor inside data frame, pandas knows how to handle everything to actually create a data frame. And then in Jupyter Notebook, if you go down question mark and then you put in your instance or your information, it will actually return the actual source code. So sometimes you read the documentation and it doesn't make sense, or you don't really understand what's really happening. You just do the double question marks and, okay, there is space there. So if you look at a data frame, it's class data frame. This is an example of inheritance. There's another object inside pandas called ND frame. So a data frame inherits features from that. And then you have your doc string, a long doc string. What I wanted to show is okay, here's your init method. It takes in the instance and a whole lot of things. Those are what do we call again? Quags, keyword arguments. with default values of none, 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 and none. The one I want to go to is shape. Yeah, there it is. So whenever we go DataFrame.shape, we don't put in the parentheses because it's an attribute, but it's an attribute that is created from a function within pandas or within the data frame. It takes in the instance itself, which is normally just df. And then from there, it returns the length of the index, which is the rows, goes down, comma, length of the columns going that way. And then it returns it as a tuple. So which is why it's dots, which is df.shape is num something dot comma something. Right. So this really helps out if the documentation doesn't make sense. And we get into a lot of those things. Now let's look at inheritance. So inheritance is basically one class getting attributes or getting its things from a different class. We're creating a class here, we're calling it mother. Mother has an eye color and a head type, right? Similar to what we were doing at the top, the one difference is for the head type, we are returning it, we're giving it that string, the upper method, as in return everything as all caps, because I want to make it an example here. And then there's another class called child. Now this child also has eye color, head type, but has a third attribute called name. So now when you're creating the child, you want the child, the only new thing it's going to come with is the name. Otherwise, everything else is going to get from the mother. And how we do that, we say the child needs three things. Two of these things come from the mother. That is the eye color and the head type. What doesn't come from the mother is the name. And to set the name, you're going to go instance.name is equals to name. The other two, get it from mom. And to tell Python that we are actually going to, or this class is going to inherit something from a different class, we use this, what is called a super method. Super basically says, whatever I'm going to initialize now, those things we're getting from the top. Yeah, or from the super class or the parent class. So, same story. So now, init happens twice here. It happens for just the child to say what the child actually has. But the first two, we're getting it from the parent class, which is go super.init, eye color, head type. And then we just pass in the name, because the name is it actually gets instantiated from the child. You're going to see a lot of this. Everything inheriting from everything else. Run this. Let's run this. Okay, so now we create mother. Mom has blue eyes and straight hair. We check the dictionary. Blue, the eye color is blue, but we check the head type. It's straight, but straight is not written in small caps. It's written in all caps because of this upper method. Right? And then we create a child. This child takes in three things. Eye color, what? Head type,
yeah.
and the name, right? So when we create the child, when you look at the dictionary, the head type is also all caps, but we've never specified anything about capping or making the head type all caps within the child. But because it's getting the head type from the mother has something that tells you, hey, listen, with all head types that comes in, make everything all caps. So that's why this object has the X this way. So it also helps out when you're reading source code or something and it's doing something that's not there. So it's because it's inheriting that feature from the parent class.
I don't know, but did you check out if Python can handle multiple inheritance? Like child inherits from mother and father. Because I know these languages that can't do that.
Python it can do multiple inheritance, but it is advised not to do it. But if it comes across something where mom has blue eyes, the father has brown eyes, there has to be, it goes for what is called a method resolution order, which is basically, there's a written code somewhere that says, this is how you act in that instance. But I think it goes to the one on the left first. But yeah, it's called MRO. That's how it decides. But under normal circumstances, don't do it.
But you can, I'm assuming you can nest inheritances like Russian doll type structures. So you can say like, you could define grandmother and say that grandmother, I turn eye color to lower.
Oh yeah.
And then you say that, then say mother inherits that from grandmother, but then child inherits from mother, who then effectively have inherited
Yeah,
from
that's
grandmother.
fine, because it's a straight
Exactly,
line.
that's
Yeah.
it.
But another thing that you're going to see is there are instances where a class seems to be inheriting from different classes, and some of the other classes are called mixins. Right? With the mixin it's a class that you don't use by itself, but it only acts when it's being inherited by something else. For example, for instance, if you were at a bar and you order a cocktail, you can't really order the umbrella by itself. You can't walk into the bar, hey, I want one of those umbrellas. I want a big one. Yeah. So by itself you can't buy it. But when you're ordering the cocktail, it comes mixed in inside the cocktail.
Like abstract classes. It's something different.
It's something different. And an abstract class is a class that is used to tell the other classes how to act or how to be created. Like if I create an abstract class, like for instance, I'm designing cars. If I create an abstract class, I can say, abstract class, a car has to have 4 wheels, it has to have this and this and this and this. So I can have a class for, let's say, BMW. I can have a class for X3, X4, X whatever. But all of those classes would have to have wheels in them. Because the abstract class says you have to have wheels, otherwise it's not a car. Yeah, it's okay. Maybe in the future, you know. Yeah, so there is that. Oh yeah, there's another thing called, when you look at privacy. Privacy has to do with that whole issue of encapsulation, as in the class can choose to hide certain things from you, or from users or anything like that. But in Python, there is no such thing as privacy. Everything is public. But there is a way of trying to get things to act in a private manner, or there's a way of trying to get things to act in a manner. We have a class here called students, and when you look at students, the construction method, the name, if you put in a single underscore, you are hinting that this thing is protected. People can still access it, but you're saying you shouldn't access it directly. Rather use a method that should be inside the class to access this thing. And if you are really serious about people not accessing those attributes directly, you give it a double underscore, but only on the front. Don't go double underscore on the front and double underscore on the back, because that's mainly reserved for Python itself. So when here, let me just place this here. Yeah, so here we're creating a student, there's a name and a surname. And there's an instance method for getting the surname, and you see in just a second. We create a student, Swoo is his name, Kiz is his surname. So we can get the name directly. But it is advised not to do that if there's a method that was created specifically for getting these attributes. But if you try and go swoo.surname, Python just says, I know, chief, yeah. No, this one doesn't work. It's not necessarily private in the sense that you cannot access it. You can access it using something called name mangling, which is an entirely different process. But most of the time, when software is being designed, you give those attributes that cannot be accessed directly. You have to put in a method of getting those things. Like for instance here, this method returns self.__ surname. So if we go spool.getSurname, that's fine. That is how we're supposed to get surname. Otherwise, maybe there might be some code that we might mess up inside the class. Yes, Rob?
So I mean, it's a bad terminology, but like, you know, in Excel, you have like, you can lock cells and you can have hidden cells. It's effectively that, right? I'm assuming it's like to prevent people from accidentally overwriting something or.
Yeah. The prioritizing things, was mostly for that.
It's a bit late, Nick. Oh, okay. The property method can set also.
A property method. Or to access something in the class. Yeah, but then it would be a setter method.
No.
Yeah, it can, yeah. So, while we're looking at privacy, so yeah, that's there. Nothing in Python is private. The entire thing is open source. Even the things that have double underscores in front, you can get it through name handling. And then now let's just go to OOP in practice. Because we are data scientists or data science practitioners, I like using that one because no one can argue with that. We look at the source code for the DataFrame. What happened here? Oh, I have one created at the top. Do I? Okay, guys, I think I just changed something. Does anyone have any idea why my dumb thing is not working?
It's reading the comment as well.
Oh, still okay. Why is it reading the
I
comment?
don't know, just take it away.
Oh, okay. I didn't. Yeah,
I wasn't
glad.
Can't comment.
So okay, yeah, with the double question marks, you can't comment.
Oh.
So I want to go to the source code for DataFrame, and where it's there we go. So when a DataFrame is being created, class DataFrame, it inherits from ND DataFrame, the actual doc string, which is what we see in the documentation. Property method, this is for accessing properties, the constructor. Okay, this thing is huge. So if you look on the side of the scroll wheel, it's not moving. But at least you get a sense of how a data frame is designed. Where are we? Okay, this is everything. So if you cannot, if something is, you don't understand how it's actually designed, you can actually go in and read the thing. Okay, this is a lot. But this is it. So, but the hope now is at least when you're looking at source code, you have some idea of what's happening. So is it data frame, why am I running type? Okay, the type check returns, okay, it's a data frame. If you want to see everything that's inside there, I don't know what a block manager is, but it's there. It has the items, which at the moment are just the index and the column and the range, which is a range index. Let's create a new one. Check for its attributes. These are the columns A, B, C. Why is it saying it's an index? Okay, then I have to look up. Because item, or maybe inside the source code, that's how the columns are written as items here. Items and then those items. Oh yeah, the columns themselves can be indexed. Yeah. And then return everything, attributes, methods, and it's a whole lot. Like a lot. But I think we can find something we normally use. There it is, to CSV. Yeah. So there's a method to CSV, to JSON, to HTML, to people, to X-ray.
XRA.
XRA, oh, okay. Yeah, guys, I've been staying here for a while. Yeah, so these are all the methods inside the data frame. So now let's go sklearn. So with this, we've written this for a while now. LM is equals to linear regression. So we created an instance over linear regression model. If you check the type, it tells you. This thing comes from sklearn based on linear regression. Look for its attributes, and jobs is none. Okay, let's just go straight to the source code. Source code, this is how a linear regression model gets created. Oh yeah, there it is. So linear model inherits from linear model. Because this we find, even in assuming that even in logistic regression, will also inherit from linear model. But this has a mixing called a regressor mixing. So it's not necessarily like a double inheritance, because a mixing by itself is never instantiated. It only works inside something else. So this is the main thing, but then it's a regression model. Docstring, 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 the constructor, so it's the instance, keyword arguments. Oh yeah, here's an important one, dot fit. So when you're training the model, it's the instance, it takes in the y value, your x matrix, your y values which come in as a vector, sample weights which I've never used, but it's okay, the default is none anyways. So to train the model, it does all of these things, which is mostly a whole lot of NumPy. But then at the end, it returns self, which means at the beginning you write ML is equals to linear regression and you're creating an instance. But once it's done once you decode dot fit, it'll do everything but then return the instance itself. Meaning LM is going to return itself. And then from that, we normally go dot fit, we give it the attributes, and immediately we go dot predict. No, we go LM dot predict. Yeah. So because the instance returned itself at the top, we take itself dot predict now. So we take the trained model. Where is it? Why is it not showing me? In it. It stopped for whatever reason. Where am I? Oh yeah, from an instance of a new model, you can only go dot fit. It'll do its thing, return itself, but it should be showing me dot predict. Let me search it. Okay, the thing has it. Okay, guys, I don't know why this documentation stops at fits. Or maybe.
Can it be in the linear model? Can you?
Oh yeah.
Maybe it's in the
maybe it's in the linear model. Yeah. See inheritance.
Yeah. Because that's probably true. Like, the way it fits is unique to linear regression, but the way it predicts is general.
It's general to the linear.
To the linear models as a whole.
Oh yeah. Thanks, guys. Because I'm wondering where, yeah, that happens a lot. You look at something like, okay, but it has this method, where is it? And I'm thinking that was it, guys. Yeah, that was it. So now I'm going to upload this notebook onto my GitHub account and also send it through on random. Yeah. Thank you so much.
Cool. Thank you.